All right, in part C, I have tan squared, and I have in the bottom secant to the fifth x. I think we should somehow like simplify this expression first, even though we have the uh, even or odd powers of tan and secant, but we have a rational function. We got to be very careful here. I would just simplify this expression first because I know that secant is 1 over cosine. You know it from the trig, right? So I can write this as like 1 over cosine to the fifth x, and I can flip the bottom over. So this becomes, let's see, this becomes um, tan squared x times cosine uh, to the power of 5x. Okay, so now I don't like the way I write this in terms of tan and cotan, so let's write everything in terms of sine and cosine. So I'm going to use the definition of tan this time from trig. It's sine squared over, tan is sine x over x, but tan squared is sine squared x over cosine squared x. I'm multiplying that by cosine to the fifth x. So now we can simplify cosines here. One is the fifth power, the other one is the second power. So at the end of the day, I have secant squared x cosine cubed x. Okay, that's good because this integral now turns out to be sine squared x cosine cubed x dx. All right, so I can go back the very first formulas that we derived earlier. We have the even power of sine and odd power of cosine. Okay, odd power of cosine. So here we go. I'm going to use number 2. Okay, all I'm going to do here is that reserving one cosine for dx and replacing cosine squared related term with 1 minus sine squared, and I'm going to call u to be sine x eventually. Okay, so let's do it. I'm going to reserve 1 cosine x for dx. Okay, let's put a border over there. All right, so I'm going to replace cosine squared x by 1 minus sine squared x from the Pythagorean theorem. Okay, very nice. So now I'm going to apply a u substitution here. I'm going to call u to be sine x. Okay, let me just do that right here, but let me just clean up this first. Okay, let's just clean everything here. I'm going to call, as I said, u to be sine x. Okay, so u equals sine x so that du is cosine x dx. Okay, sounds good. I am going to continue right here. Okay, so I have u squared, 1 minus u squared, and du. Okay, so let's expand this out. U squared minus u to the fourth du. And now I can integrate this in one shot by using the power rule for integration, right? So u cubed over 3 minus u to the fifth over 5 plus c, okay? And u is sine x, so I'm done, right? Sine cubed x over 3 minus, right? Minus sine to the power of 5 x over 5 and plus the integrating constant. All right. So this was sort of like this was an easy application of one of the guidelines, but the hard part here in this question is to see that you got to convert this integrand to something involving sine and cosine only. So we were supposed to we were using the definition of tan and secant, and tan is sine over cosine x, and secant is 1 over cosine x. So we got an alternate formulation here, right here, in fact, right? Alternate formulation of the the same integral, and we applied the guidelines that has cosine raised to the power of 3. Okay, so it's an odd power of cosine. All right. I think that's the end of it. We just got done with part C. Again, not all the integrals here in the list require the use of the guidelines mentioned in the lecture notes. Okay, so sometimes just one u substitution is enough to take care of the given integral. So, all right, I'm going to end the video here, and I'll see you in another video. Bye.